Hi, and welcome to Dr. Pat TV. We're looking at part 3 of our linear and economic term review here. Getting ready for our business calculus coming up. And so one of the things that we're looking at is our cost function. Our typical cost function is the addition of fixed cost and variable cost. Put those two things together and you've got your cost function. Um, Fixed costs, if you don't recall or you haven't had your business class yet, basically fixed costs are those costs that don't depend on how much you produce. So if I'm producing coffee espresso beans, chocolate espresso beans, then basically I've got a machinery, I've got my lease, I've got my mortgage, those kind of things, and those things don't depend on how many I produce. And so that would be a fixed cost for me. So how much the lease of my machinery and the place that my factory, and that's fixed cost. Now variable cost, that depends on the number that I produce. So for my chocolate coffee beans, espresso beans things, I would have a cost, variable costs associated to how many I produce in terms of the supplies of coffee beans. I would have a variable cost in terms of the chocolate that I need. If I'm making my own chocolate, I've got cocoa, I got milk, and I got all those things. And the cost of that all depends on how many I produce. So that's the idea of variable cost. It's the part that varies. Varies depends on the number. Without using the words, our total cost function is basically TC equals FC plus VC. So FC for fixed costs, VC for variable costs. Seems kind of straightforward. But if you have a linear situation, then your marginal cost, that's what MC is. Marginal cost is just marginal cost times Q. Marginal cost is a business related term that looks at how things are changing, the rate of change. And so in a linear situation, marginal cost, this rate of change, would be the slope. So for an example, I'm looking at Duff Energy Drink. They produce 1,000 cases at a total cost of $6,000. When they produce 1,500 cases, the cost is $8,500. Let's assume a linear situation. And what we want to do is we want to find the projected total cost for a production level of 2250. And so in order to do this, I need to develop the formula. Once I develop the formula, then I want to plug in 2250. So that's kind of my strategy. Make the formula and then do the evaluation. So the data points I'm playing with are 1,000, 6,000 from that first data point. The second one was 1,500, 8,500. And so we calculate the slope. We pick one of the points in to calculate the b value, and we would get a nice linear formula of cost equals 1,000 plus 5q. So using those techniques, developing the equations from part 2, we basically would end up with that formula. The next stage, once we have our formula made, is that we need to substitute our 2250 in. And I'm just taking that quantity, that Q, replace it with the 2250, crunch it all out, and I get a total of 12,250. So there's an example of where we could use our business example, our situations, along with our math linear situations. Another one that we have is a very common, very popular business concept, and that's revenue. Revenue is the formula, that's price times quantity. And a lot of times you see that as TR, or just plain R, equals P times Q. So PQ, P for price, Q for quantity. And basically, if you're going to only learn one thing in this term, let's hope that you've got your revenue is price times quantity. Another economic formula that we play with is profit. Profit is basically, a nice simple version of it, is revenue minus cost. So profit equals total revenue minus total cost. TR minus TC, or R minus C if you don't want to say the total. And again, if you're in your own business, you really want to know this, because this is where the money is. You want to make sure that you've got a profit. Okay, so now let's put it together with more of that Duff example. This time I've got, we're selling it, so that's the price that we're selling it to other people. Not a cost to us, it's a cost to other people. It's the price that we're selling it to others at $24. And we want to ask the question, the questions are, what's our revenue at $22.50, and then what's our profit? Well, if our price is 24, that makes our revenue formula a nice straightforward 24Q. Multiply by the number of cases, the 2250, and we get a revenue. So if we're selling them at $24 each and we sell 2,250 of them, then we've got a nice revenue of 54,000. And then for the profit of those cases, we're just doing revenue minus cost. So we have the revenue, we just calculated that. We have the cost, we calculated that on the previous slide. And so together, when you take the difference, you subtract that, we've got a profit of 41,750. Okay, so there's some nice straightforward examples, the business examples where we could use linear situations. The next one we have is demand and supply, and I'll do that in part 4. Thanks and have a good day.